Hello YouTube and welcome to the Math Tricks video. In this video, I'm going to talk about the second formula for solving quadratic equation and factorizing techniques. Further, we will use the combination of the first formula, which is explained in the previous video, and the second formula. So if you haven't watched the first video, please do so. So formula number 2 is a square of sums, and if we say m plus n squared equals to m plus n times m plus n, which can be written as m squared plus 2mn plus n squared. So we will go through example 2 to clarify the idea. So we would like to find the roots of function fx equals to x squared plus 6x plus 9. So here, because we would like to solve all kinds of quadratic equation, I will give an algorithm to this, keeping in mind that we have this equation, and in general we have a standard form of a quadratic equation as this. So keeping in mind that, we can present an algorithm to solve all kinds of quadratic equation. So we would like to make sure a equals to 1 for a first step. So here we can see we have just x squared, so it means that a equals to 1. After doing that, in step 2, we write whatever we have here, I mean the first expression and the second one. So ax squared plus bx. In step 3, we add and subtract b divided by 2 squared. And then in the fourth step, we rewrite what we have for c. So we go through alternative 1. I put it lucky case, and you will see why in a bit. So we made sure that a is equal 1. We were lucky here, a was equal to 1, so we write x squared, and then we write this expression as it is, plus 6x, and then we have, of course, b equals to 6, so we add and subtract 6 divided by 2 squared, and we subtract 6x squared, 6 divided by 2 squared, and as you can see here, the sum of these two guys are 0, so we did nothing illegal. And then we write c, coefficient c, and then we write, okay, we would like to find the zeros, so we put this one equals to 0. So if we look at these guys, we get something interesting, and I claim that these first three terms are equivalent to this formula. Let's see why. So I rewrite this equation explicitly. So x squared plus 2x times 3 plus 3 squared. So you can see this equation is equivalent to this one. So we can rewrite this as in this form, which is x plus 3 and the whole guys squared. And then we rewrite what is left, so minus 3 squared plus 9, which is 0. We got 0 here. That's why I put lucky case for this one. And then equals to 0. So this one, x plus 3 squared, so this is nothing but x plus 3 times x plus 3, and is equals to 0. So we have two cases again. Either this expression in the first pair of parentheses should be 0, or the second expression in the second pairs of parentheses should be 0. So x1 is equal to minus 3, or x plus 3 equals to 0, which yields x2 equals to minus 3. So here, as we remember, a quadratic equation has to have two zeros. And we got two zeros, but they are the same. So alternative 2, we can use the formula. So we say, okay, minus b plus minus b squared, which is 6 to the power 2 minus 4, and coefficient a was 1, and then times c. So we get 36 here, and here we get 36. So the expression under square root will be 0, and then we divide by 2a, which is 2 times 1. So minus 6 plus minus 0 divided by 2, which gives minus 6 divided by 2, which is equal to minus 3. So we have two roots, x1 and 2, both of them are equal to minus 3. And again, if we draw the graph, we will see that this graph has a smiley style, and it crosses or touches, it doesn't cross, it touches x-axis in the point minus 3. So again, we can see the vertex of this graph, which has coordinates minus 3 and 0, because x is minus 3 and y is equal to 0. So we have lucky case here, and let's see what does it mean with unlucky case. So we would like to go through this one. At this point, we remember that p squared, our first formula was p squared minus q squared is equal to p minus q times p plus q. And we present the second formula in this video. So we would like to combine this to solve another quadratic equation. So I called it a combination of formula 1 and 2. So example 3. In example 3, we would like to find the roots of function fx equals to x squared plus 6x plus 5. So we recall our algorithm. So we make sure that coefficient a is equal to 1. Yes, 1x squared. And then we will rewrite ax squared plus bx, which is these two first expression, x squared plus 6x, and then we add and subtract b divided by 2 squared, and then in step 4 we rewrite whatever is for c. So we go through unlucky case. So we made sure, okay, we made sure that a is equal to 1, so we write x squared plus 6x plus 6 divided by 2 squared minus 6 divided by 2 squared, and then we write plus 5, and we would like to find the zeros of this function, so we will put it equal to 0. Please observe that the sum of these two guys is 0, so we didn't change anything in the first function. Again, if we rewrite this equation in a standard form, we will get x squared plus 2x times 3, which is the value of this one, or the value of n. So we get ms squared plus 2mn plus n squared, which is familiar for us. It is in the equivalent form of this one, so we can write x plus 3 squared, and then we have these two guys. So minus 3 to the power 2 plus 5, which is minus 4, and then equals to 0. So if we look at this one, I can rewrite this here, and then we said this is x plus 3 to the power 2 minus, and 4 I can of course rewrite it as a 2 squared. Yes, and then equals to 0. So when I write this one in this form, we have expression squared and another expression squared. So we have this whole expression in the parentheses is equivalent to P, and this 2 is equivalent to Q. So we will get x plus 3 squared minus 2 to the power 2 squared, which is equivalent to Q squared, equal to 0. So again, now we can write these guys in this form. So we can write x plus 3 minus 2 times, again, x plus 3 plus 2 should be equal to 0. So to have this equals to 0, this expression should be 0 or this expression should be 0. So we can write x plus 3 minus 2, which is nothing but x plus 1 equal to 0. Thus one of the roots are or is minus 1. And then if we write the second expression, x plus 3 plus 2 is x plus 5. So x plus 5 should be 0, and then x2 is equal to minus 5. So if we draw the graph for this, we will see that again we have a smiley graph, and this comes through the fact that x squared has a positive sign, and this graph went through x-axis in 2 points, minus 5 and minus 1. And it has a vertex with coordinates minus 4 and minus 4. Oh, sorry. The vertex has coordinates of 1, 2, 3, minus 3, and 1, 2, 3, 4, plus 4. So, a funny and interesting fact about the vertex is, if we look at this expression, it is a squared, so it never can be negative, meaning that it's always 0 or positive. So to get this one 0, we put x equal to minus 3. So if we put minus 3 plus 3 will be 0. So this one gives the x coordinate of this graph vertex. And if this one, the whole expression here is 0, then we get minus 4 here, which is y coordinate of this vertex. Interesting, isn't it? So let's continue our discussion with the combination of formula 1 and 2. And we have challenge 2 here. 5 minutes, I think it's a fair time to find the roots of function f(x) equals to 2x squared plus 5x minus 3. If you want, of course, you can pause and try to solve this quadratic equation and find the roots of function f(x), or you can directly continue watching. So again, we have make sure that the coefficient a is equal 1. Here we don't have 1, so we have to factor out 2. So we will do that to make sure that the coefficient a is equal to 1. We factor out 2, and then we have 2 times x squared plus 5 divided by 2x minus 3 divided by 2. Then we would like to find the roots of this function, so we put our function f(x) equals to 0, and this is unlucky case. So we would like to have or to find the roots of this function. We write what do we have here, and then we put it equals to 0. So again, we write x squared plus 5 divided by 2x, and then you remember, of course, the third step, we would like to write b divided by 2 squared, but b is here 5 divided by 2, so 5 divided by 2 divided by 2 is 5 divided by 4, so we write it plus 5 divided by 4 squared, and then minus 5 divided by 4 squared, and then plus c, which is here minus plus minus, which is minus, of course, 3 divided by 2, and this should be equal to 0. So again, we can rewrite these first three expression as this one. So x squared plus 2x times 5 divided by 4 plus 5 divided by 4 squared, which is equivalent to this formula, where m is equivalent to x, and then n is equivalent to 5 divided by 4. So we can write this one as x plus 5 divided by 4 squared, and then we rewrite these two, minus 5 divided by 4 squared minus 3 divided by 2, which is 25 divided by 16, minus, if we want to make a common denominator, we multiply this one with 8, then 8 times 3 is 24, minus 24 minus 25 is minus 49 divided by 16. So we want this to be equal to 0. Then we write this expression as it is, and then we write this one, so minus minus, and the square root of 49 is 7, the square root of 16 is 4, so we have 7 divided by 4 squared, and now we have equivalent form to this one. So we can write this one as this expression plus this fraction times this expression minus this fraction. So we have x plus 5 divided by 4 minus 7 divided by 4 times x plus 5 divided by 4 plus 7 divided by 4, and we would like to have it equal to 0. Then again, either this expression should be equal to 0 or this expression should be equal to 0. So we will write them here. 5 divided by 4 minus 7 divided by 4 is minus 2 divided by 4, so x equals to 1/2, and then we have plus signs here, so 5 plus 7 is 12, and divided by 4 is 12 divided by 4 is 3, then the second root of this expression is minus 3. So here we get the graph representation of this, and then we see that function fx crosses x-axis in 2 points, namely 1/2 and minus 3. And again, we have a vertex here, and this vertex has following coordinates. Can you? Yes? So again, this expression in the parentheses never can be negative, and the minimum amount this expression in the parentheses can get is 0. So to get this 0, we have x equal to minus 5 divided by 4, which is x coordinate of this vertex. And if we have 0 here, so y will be 7 divided by 4 squared, which is 49 divided by 16. So the y coordinate of this vertex is 49 or minus 49 divided by 16. Okay, here we end up with the second important formula to solving quadratic equations. We also did go through the combination of the first and second formula. Please subscribe if you like the video, and I will talk about the third and the last formula in the next video. Thanks for watching.